So let us start the first session of our course Network Primer. So this is the first part of Network Primer. The following topic would be covered in this Network Primer topic, starting from overview of the networking and benefit of network, then different components required for forming a basic computer network, and communication channels involved in the computer network, as well as different types of nodes that can be participated in a computer network. Then client-server model, different types of server, role of a network administrator or equivalent role, network segmentation, LAN traffic congestion, and Ethernet, CHMA, CD, internetworking, basic and broadcast domain and collision domain topic would be covered. Then we will go through the hub, switch, router, and repeater. So we will compare all these devices with respect to our requirement. Then different types of cabling, then internet protocol, TCP/IP models, OSI reference model will be covered. Then port number will be covered. Then TCP/IP and associated protocol like TCP and UDP will be covered. We will also go through the different types of addressing mechanism used in TCP/IP protocol. For example, IP address, MAC address, and different types of logical addresses and physical addresses that are part of our computer network system. Then different protocol data unit will be also covered, like ARP protocol, TCP, then their header format will be studied, then TCP flag. So different types of flags available in the TCP protocol data unit as well as in UDP, then format of IPv4 header, then common protocol number. So every protocol have been assigned a number. So what is the common protocol numbers assigned to different protocols in the TCP/IP software stack? Then ICMP protocol and different types of message in the ICMP protocol, different types of code in the ICMP protocol will be covered. Then we will go through the finally Ethernet frame format. So starting from basic concept on networking. So basically we are going through the computer network. With respect to our topic, we are focusing on computer network. So simply a network is a set of devices. So set of devices can be a node, it can be a personal computer, or it can be your mobile device, or any device which is capable of sending or receiving data from other device. So it is a set of devices that are connected by means of communication link. A node can be computer, it can be a network printer, or it can be any device that can send or receive the data generated by other node on the network. Connecting equipment together with the help of communication channel is known as computer network. And there are some examples of communication channel. The communication channel can be a physical cable, it can be phone line, it can be unguided media like satellite communication system, copper wire. Similarly, some cable can be used like copper wire, optical fiber cable, and other unguided media can be radio wave, infrared communication, Bluetooth communication. So basically, radio wave can be used in electronic communication industry, and radio waves is used in our Wi-Fi network. Similarly, radio waves is also used in Bluetooth communication. So there are variety of communication channels are there, and with the help of this communication channels, we can interconnect node device in the network. So this will form a computer network. And this equipment or node can be a personal computer, it can be a mainframe computer, or it can be a network printer, it can be a plotter, it can be fax machine or mobile device. We can go through the different examples of communication channel. So for example, in wired communication channel, we can have Ethernet communication channel. So Ethernet is basically used for LAN connectivity, LAN communication. So which use some twisted pair types of cable. So there are different category of cable that can be used in Ethernet technology. So it is very common standard for LAN communication, Ethernet. Then optical fiber is there, which can be used to transmit the data with the help of infrared light or laser light. So this laser light or infrared can be used to transmit data with the help of optical fiber cable. Then coaxial cable is there. So these are the some examples of communication channel, basically guided media. And with respect to unguided channel like wireless communication channel, there can be Wi-Fi. So Wi-Fi is commonly also known as IEEE 802.11. So there are some different standards under 802.11, 11A, 11B, 11C, 11G, 11N. So there are many standards are present in Wi-Fi. So depending on which wireless LAN technologies we are using, which particular wireless LAN standard is supported by our wired and wireless and IC cards, will decide which Wi-Fi network you are going to connect. So wireless communication for LAN, normally Wi-Fi is used for LAN communication, and it is operated on frequency band of 2.4 gigahertz and 5 gigahertz frequency band. So it depends on which particular standard you are using in your Wi-Fi network. Similarly, Bluetooth is also example of communication channel that also use the radio wave, and it is mainly used for personal area network, PAN area network, like our Bluetooth, earphone, our smartphone, smart watch. So all these wearable devices are basically getting connected with the help of Bluetooth communication device. Our sound system, so all music system can be interconnected with different speaker with the help of Bluetooth communication channel. Then cellular networks are there, 3G, 4G, 5G are there. Then infrared communication can be also used for short range communication using infrared light wave. So the most common example is our TV remote, which can use infrared communication, and some of the devices, some of the smartphone or laptop or desktop devices have a infrared module for communication based on infrared signal. Then satellite communication is there. So these are the different communication channels example. Similarly, there can be different nodes in the computer network, because with the help of communication channel, we can connect different types of nodes to form a computer network. So this node can be our end device, user device like desktop PC, laptop, tablet, smartphone, smart TV, game console, smartwatch, virtual reality headset, smartphone devices, smart home devices. So basically, these devices are capable of sending or receiving data by means of communication channel. So that is why it is known as a node. So it can be treated as a node in the computer network. Similarly, we can have IoT device like smart sensor, smart appliance, wearable fitness tracker. Similarly, we can have a network device like a hub, router, switch, wireless, Wi-Fi access point, modem. Then we can have different types of server depending on which type of server we are providing with the help of server like web server, email server, file server, media server, streaming server. So there can be different types of server can be possible to be configured as a node in a computer network. Then there can be voice over IP phone, there can be IP camera, then there can be storage device which is connected to a network. For example, network attached storage or storage area network. So these are the example of storage device which is connected to the network. So this storage device can be also a part of computer network, and it can be also treated as a node of the computer network. Similarly, cloud storage can be there. So cloud storage is located on some remote location on the cloud service provider zone. So this cloud storage can be also treated as node. So node simply means capable of sending or receiving data. If these features are available in the particular device, then it can be treated as a node of a computer network. Then peripheral devices are there, printer, network printer or scanner device can be also treated as a node in the computer network. So coming to the benefit of network. So benefit of network is mainly hardware sharing. So if we have a computer network, we can easily share the hardware, like hard disk can be shared, our printer, single printer can be shared. So now coming to benefit of network. So basically, with the help of computer network, we can easily share the hardware. Like we can share the hard disk to other user also with the help of computer network. A single printer can be shared to 10 to 20 users in our office. Similarly, plotter, modem can be also shared. So hardware sharing can be made possible with the help of computer network. Similarly, software sharing. So with the help of computer network, we can easily share the application software as well as data stored in a particular ecosystem. Participation in communication system. With the help of computer network, we can easily participate in the communication system like voice communication system, chat system, voice over IP system, email communication system. Then there is one more benefit, accessing computer running diverse operating system. So with the help of computer network, it is possible to access different types of OS. Suppose my laptop is having Windows OS, but I can access the file of Linux operating system. I can access the file of Android mobile phone. So two different OS can communicate with each other. It is possible only because of computer network. File sharing is possible, service sharing is possible. So service sharing means we are trying to offer some services. So these services can be easily shared with the help of computer network. So web services, name services, storage services, video services, audio services. So these services can be shared to other users with the help of computer network. Sharing internet connection. So if we have a single internet connection by means of internet service provider, so this internet connection can be shared to multiple users in our office, in our home, in our colleges. So internet connection can be also shared with the help of computer network. So ultimately, the sharing of data, information and devices is known as resource sharing, which is the ultimate goal of the networking. The way in which network offer information and resource sharing is basically done with the help of service. So suppose you want to publish some website, you want to host some website on a server. So for this purpose, you have to configure the web services on the particular system. If you want to offer video services, then appropriate video service should be configured and installed on the system. Then you will be able to share the particular video services for the other user. So all the services is basically responsible for providing the services in the computer network. Now coming to computer network, again, component of computer network. So there can be some set of hardware and software that can be useful in creating a computer network. So at least node device must have a network interface card, an IC card must be there. So it depends which types of communication you want to achieve. If you want wireless communication, then you must have wireless and IC card installed on your device. So this device can be a laptop, this device can be your mobile phone. So depending on types of communication, appropriate an IC card must be there. If you are interested in Bluetooth communication, the Bluetooth card must be installed on the physically present in your motherboard or mobile. So an IC card is minimum requirement to get connected to a particular network. Then so depending on which types of communication cable you are going to use, accordingly an IC card can be different for different types of communication channel. For optical fiber, there can be different types of an IC card. For wired cable, there can be different types of an IC card. Similarly, for Wi-Fi network, there is a Wi-Fi based an IC card. For Bluetooth module is different. Then there can be cables and connectors. So depending on which types of communication link you are going to use, there can be different types of cable. It can be optical fiber cable, or it can be copper cable, it can be phone line, and accordingly there will be some connector. Then there are some devices is also required in most of the cases, like hub device, switch device, router, modem. So these are the components, basic components that are required in the computer network. Now again coming to how when we want to form a network, what is the minimum requirement? So at least two computers must be there. A single computer cannot be used uh, as a part of some computer network, but this single computer should be connected to other computer or other network by some means. So at least two computers should be there. These two computers can be two mobile, or one mobile or one laptop, or laptop to laptop, or laptop to desktop computer, or laptop to network printer. So these two devices should be there. At least two device or node must be there. And on each device, there should be network operating system. So network operating system is a special system software which is capable of network operation, which can control the network operation. For example, today, whatever operating system we are using, all of the operating system today are generally categorized as network operating system, whether it is Windows 7, Linux, Ubuntu, or Windows 11, or Windows 2003 server, 2022 server. Every operating system is today network operating system. So network operating system means operating system plus network supported software is integrated in the particular operating system will be treated as simply NOS. NOS means network operating system. Then network protocol that set the communication rule. So basically the NOS operating system, network operating system is having a special system software which is known as TCP/IP software. So this TCP/IP software is responsible for all network operation. So this TCP software so yes, yes. So so we have some network protocol. There should be some software. There should be some system software that can help in network communication. So this special software is currently, for example, in our case or whatever network communication we are participating. So TCP/IP software is the special software that is governing the overall communication in the computer network. So this TCP/IP software basically defines the set of rules in the form of software communication, in the form of communication technology with the help of TCP/IP software. So it basically defines how data will be sent, how data will be received, and what will be the transmission technology, in which format data will be transmitted, and which software will receive this data. So all this large number of set of rules are basically defined in the form of TCP/IP software. So TCP/IP software is currently industry standard, de facto standard network protocol, which is almost used by all types of nodes in the computer network. Whether it is your smart TV or smart refrigerator or Alexa device or your smartphone, every device is capable of participating in computer network is installed with TCP/IP software. In addition to TCP/IP software, there were some older obsolete network protocols was there like IPX/SPS. So this IPX/SPS is basically developed by Novel Network. Uh, so it is also known as Novel Network Protocol. But today TCP/IP is the de facto standard in almost all devices have a support for TCP/IP software. But in some cases, you can find multiple support for different types of network protocol like TCP/IP software, IPS, XPS. So some of the router device capable of supporting IPS, XPS. So in case if there is a operating system running with IPS, XPS, they can facilitate communication between two devices. One is running with TCP/IP and second one is running with IPS, XPS. Then to achieve intercommunication between these two devices with different network protocol, a device will be required. So this device can be a router which can facilitate communication between these two devices. So basically, we have to focus on only TCP/IP. Then there is a NetView is there. So NetView is also a type of network protocol which is mainly used in the Microsoft-based operating system. Then there is a Apple Talk is there. So Apple Talk is supported by Macintosh operating system. Similarly, there is some proprietary network protocols are there. System Network Architecture, SNA, it is IBM proprietary network protocol. So currently we are mainly dependent on TCP/IP software. Our entire internet, our entire network communication, whether it is happening on the mobile communication or it is happening over the computer network or LAN, WAN, MAN, PAN, everywhere we have TCP/IP software in our device. In addition to that, operating system plus some software, network software, in our case it is TCP/IP software. In addition to that, some network hardware might be required. So depending on which types of topology, which types of network scenario you are creating. So at least an IC card must be present on each node. This NIC card can be wireless, wired, or Bluetooth or optical fiber based. And a device can be also required, networking device like hub, switch, router, modem, or router for WAN communication can be also required in some of the cases. Network or communication medium over which data will be sent. The physical or unguided medium where we are going to transmit the data. So this data can be transmitted through the cable, it can be transmitted over the telephone line, or it can be over the wireless devices, the wireless communication channel, satellite communication channel, or this signal, the data signal can be transmitted in different types of format, like it can be transmitted in electrical signal also, it can be transmitted in light wave also, or it can be transmitted in the form of microwave or radio wave or infrared wave. So depending on which types of communication link you are going to use. There is one more term, client server model. So client server model in computer network is basically, it is a concept in which one or more computer act as a server computer. Server computer provides some services to client computer. So client computer make a request for a particular service. For example, when we visit some website, like we are using some Internet Explorer browser, some web browser like Internet Explorer, Google Chrome, or Firefox, Mozilla Firefox. So basically, with the help of this application software, we are trying to access some web server where website is actually hosted. So entire web page is hosted on the particular server. So it is known as website. So when this web page and domain name all are integrated with each other, it becomes website. So client server model is a model in which a client computer makes a request to the server computer for a particular service. And depending on the requested service, the server will provide the service. So this is very important with respect to cyber security, because everywhere we are using some types of services. So for a genuine user or in a normal scenario, a client can make a genuine request to the server, but the same genuine request can be manipulated by attacker to send manipulated, false, bogus request on the server. So client server model is simply a model in which client computer is requesting for some services, and server computer is providing the particular services. So depending on which types of services hosted on the server, there can be different types of server like application server. So application server means database server. It can be a video server. It can be a particular application server like ERP is hosted on a server computer. It means it is a ERP server. So if a particular type of application services is configured for sharing, then it will be treated as application server like database server. Similarly, audio video server, chat server, fax server, FTP server, mail server, news server, proxy server, telnet, web server. So there are unlimited list of different types of server depending on which types of application or system services you are going to share. So there can be a web server, there can be a DNS server, there can be a DHCP server. So depending on which services you have shared and configured. Now coming to the cyber world again. So basically why we are learning this computer network, because there are many parameters are there in the computer network, and while analyzing a computer security problem, or as a investigator, as a law enforcement agency, or as a system administrator, or a administrator who is responsible for maintaining the security posture in the organization, he or she must be aware with all the different types of addresses used in cyber world. So it is very common, like in general, in cyber world, there can be different types of address parameter associated with the node, like IP address, internet protocol address, MAC address, media access control address, email address. A particular user can be identified by with the help of special email address. Then a website, a particular web resource can be identified with the help of URL, uniform resource locator, or simply web address. So there can be different types of internet resources. So if we have website, then we will have a web address. If we have some other services like FTP service, then we have URL for FTP services. Then physical mailing address, then domain name, then Bitcoin address, then social media profile URL, then phone number, then GPS coordinate, then port number, then DNS ecosystem, IMEI number, then SIM card number, then autonomous system number. So this autonomous system number is basically a part of routing protocol in which a company, a organization is assigned a special number for entire infrastructure. For example, if a BSNL is operating some router in their network, so all the routers will be identified by a particular autonomous system number allocated by Internet Assigned Number Authority. So there is an organization, IANA. So IANA is mainly responsible for distribution and coordination of public IP address, MAC address, and autonomous system number, as well as it is also responsible for allocation of port number to the different types of services. RFID tag can be there. So RFID. So basically, this parameter is associated with node. So there can be different module in a node, and each module can have some unique number or unique identification code or tag. Then Bluetooth address, then voice over IP. So it depends on where the VoIP is hosted. Accordingly, there can be VoIP IP address can be there. Wi-Fi SSID. So whenever we connect to Wi-Fi network, there should be some SSID of the Wi-Fi hotspot or Wi-Fi access point. Then account username, then API of the particular web services, then virtual MAC address, then device serial number, device part number, physical hardware address, then digital certificate thumbprint, biometric ID, IPv6 address, location-based services address, file path, URL, electronic identification number, EIN number. So these are some common examples of addresses used in cyber world, and many times it is very helpful as a evidence to investigate a particular types of cyber crime in the digital world. Similarly, in mobile communication, we can have device IP address, we can have MAC address of the mobile, because mobile is using NIC card. So this MAC address basically present in the NIC card. So media access control address can be found in the NIC card. So our mobile, our smart TV, our laptop, or any device which is having the NIC module must have some MAC address as allocated to them. Then there is a IMEI number. So this IMEI number is allocated to handset. Then SIM card number, SIM card ICC ID number. So integrated circuit card identifier, then GPS coordinate, cell tower ID, location, Wi-Fi SSID, then Bluetooth MAC address, then VoIP, then mobile network IP address, device manufacturer's address, then app specific API endpoint. So app specific application programming interface endpoint means if my mobile is using some particular app, but it is in the background, it is getting connected to some third party API like Google API or Facebook API. So this API can be also helpful in getting the log details and useful address parameter connected to my app. Similarly, mobile operator, system version, mobile browser, the mobile device, serial number, cell tower, signal strength record, then mobile app installation path URL, voicemail access, mobile carrier IP address, virtual MAC address. So these are the some parameters associated with mobile. Similarly, for banking system in ATM, there is a ATM machine ID, card holder name, card number, PIN, ATM, transaction, timestamp, card schemer, device ID. So card scheming is basically a device used by fraudster, a malicious user, to get the copy of plastic card. Then IP address of ATM network, MAC address. So there can be different types of addresses parameter that can uniquely identify a particular modules or hardware device or a user in the digital ecosystem. Similarly, in internet banking ecosystem, there can be IP address of customer, client, and IP address of the server, then UPI ID, UPI gateway IP address. So these are the different parameters associated with banking system. Similarly, if the services are hosted on the cloud platform, because when we are hosting our server or computer in our campus network or our corporate network, everything is being identified with the help of corporate identity. But if the same hardware or software is hosted on cloud service provider, then we have to depend on the IP address, public IP address of the cloud instance, MAC address associated with the cloud service provider, URL, domain name of the cloud service provider platform, API endpoint address, account, email address associated with the cloud service account. For example, if you are hosting your virtual machine or services like platform as a services, software as a services, hardware as a services, infrastructure as a services on a particular cloud platform, AWS, Microsoft Azure, then you have to create a registration on this particular cloud service provider platform by providing email address and several KYC related data, plus some payment related instrument need to be provided in the. So this different addresses and parameter can be useful as a evidence in the cloud service provider ecosystem. Then some virtual network IP address, load balancer IP address, cloud provider, domain name associated with the services hosted on the cloud platform. Then internet call, voice over IP call, there can be IP address of VoIP server, MAC address of the VoIP server, VoIP gateway IP address, who is providing this VoIP services, and our call is getting routed through different routers. So what is the VoIP gateway IP address? Then VoIP account ID, call detail record, data detail record. So CDR, DDR can be also helpful. Then there are different types of call signaling logs can be helpful. Then if we are using multimedia based communication using SIP, then we can have some SIP based address, SIP IP address, RTP based address, caller ID information, timestamp. So this can be different information useful as a evidence in internet call and VoIP services. Similarly, in drone, if we are talking about the drone, so because drone is a device, is a unmanned aerial vehicle, but there are some modules like there can be Bluetooth module, there can be an IC card in the drone, there can be GPS module. So there can be different types of module present in the drone device. So with the help of this module, address and parameter, we can have some addresses like UAV serial number, drone operator IP address, MAC address present in the drone and IC card, GPS coordinate, radio frequency, identification tag ID, Wi-Fi SSID to which drone is connected, SIM card. If this drone is having SIM card module, then what is the SIM card number associated with this drone? So these are the list of. Similarly, a drone can have a camera. Then camera is provided by which company is providing this camera services. So there must be some serial number in the camera. Then we can interrogate with the camera service provider that you have supplied this device to which user, whom to whom. So this can be helpful. Similarly, on IoT platform, Internet of Things, because Internet of Things is not a new thing, we are just using a small computer, and with the help of this small computer, we are controlling some of the activity, and we are sending and receiving some data with the help of IoT device. So Internet of Things. So all devices are getting connected to LAN and WAN or Internet. So that is why it is known as Internet of Things. So Internet of Things can have their own IP address. There can be some public IP address associated with IoT device. Suppose my air conditioner or AC or refrigerator is a part of IoT. So I am checking the status of home appliance from IoT capable app. I am controlling all the devices from IoT based app. So definitely there will be some IP address associated with my refrigerator, my air AC equipment. So all the IoT capable device must have some IP address. And this IP address must be present behind some unique parameter like a public IP address that can be used to identify the presence of IoT device in the network. Similarly, IoT device can communicate with some cloud platform. It can communicate with third-party APIs. So in this way, when we are making connection to any of the resources or computer or server, our activity is getting logged at the level of server. So there can be IoT device IP address, there can be MAC address, there can be MQTT, broker IP address, there can be IoT gateway IP address, there can be Bluetooth low energy address. So basically these are the terms related to communication industry. So RFID, device manufacturing server IP address, IoT hub URL. These are the different addresses which can be helpful as a evidence in the IoT. Similarly, in stock trading, if someone has registered an account with the stock trading platform, there can be stock trading account ID, demat account number, and several IP address associated with client from where stock trading were performed, malicious stock trading were done. So these are the different addresses for the stock trading platform. For Facebook platform, for social media platform, there can be some unique parameter like Facebook user profile URL. Every user have unique profile URL. IP address of Facebook server, IP address of Facebook client from where the Facebook account was accessed. MAC address of the device, URL, Facebook account ID, timestamp of user activity, location metadata from post. So if some user have posted some photograph on the Facebook platform, so every photograph, every file has some metadata. So this metadata can contain location information, longitude, latitude. So if you are trying to capture a photograph from your GPS capable mobile, which can store GPS information, longitude, latitude information in your photograph, then this type of photograph can be tracked. Where this photo was captured, when this photo was captured. So all informations are present in a particular photograph. So when users is posting some photograph on the Facebook or any other social media platform, the metadata can be helpful for getting some of the useful parameter, device information, device ID, then Facebook API endpoint, then unique identifier for Facebook app, then chat message, timestamp and content, then Wi-Fi devices associated with because when we are talking about the client IP address, so this client IP address can come from internet service provider on the mobile, or it can come from Wi-Fi, it can come from the mobile service provider, internet services, 3G, 4G. So depending on which services the user has used, accordingly IP address will be allocated from the service provider. So how many account recovery email ID are associated? What is the contact number provided with the particular Facebook URL, Facebook account? So this information can be helpful for as a evidence. Similarly, WhatsApp can have some information like WhatsApp user phone number, then IP address of the WhatsApp server, then MAC address, then device information, then WhatsApp account ID, then timestamp, location metadata from shared location. So this metadata is helpful. We will cover all this topic in digital forensic part. Then media file hashes, image, video. So there are different types of. Similarly, there can be group chat URL, there can be call and video call log with timestamp. There can be some services which was used in the WhatsApp platform. Similarly, Telegram can have some useful parameter and address. Similarly, YouTube streaming has some information like YouTube channel URL. So every channel have a unique URL, and so this unique URL can be helpful for finding some of the details, because while investigation, your channel URL must be present, and some logs related to URL channel will be provided by YouTube. So it depends on investigation scenario. IP address of YouTube server, MAC address, URL, domain name of YouTube platform, video URL, ID, then user account ID and Gmail account associated with user ID, YouTube account, device information, device ID, OS, YouTube API endpoint, video uploaded on the YouTube channel. So this video can be also helpful. Playlist URL, comment in the particular video, video analytic data, like, dislike, shared, comment, ad campaign URL. If some user is posting the ad on the particular platform, so each ad have some unique ad ID. For different platform, every YouTube ID has some ID associated with the poster who have floated this ad. Suppose I am going to submit some advertisement with the help of YouTube. YouTube will record some unique ID against my request. So with the help of this ad, we can have some information. Similarly, Facebook have some unique ID. Google ad have some unique ID. So Google Ads have campaign URL and ID, IP address of the Google Ad server, MAC address, URL, advertise. advertiser account ID, timestamp of the ad campaign, advertisement URL and ID. So these are the different parameters associated with Google Ads. Cryptocurrency has some information like wallet address, then blockchain URL, then transaction hash, then IP address of cryptocurrency exchange, MAC address, API endpoint for the cryptocurrency transaction, public key of cryptocurrency wallet, then cryptocurrency exchange URL, Bitcoin address. So there can be different method, different addresses, different parameters that can be treated as evidence in the cryptocurrency world also. Now coming to role of person involved in managing the network. So it can be network administrator or depends on scenario. There can be IT manager, there can be different types of job roles in different industries. So accordingly, a person who is monitoring the network services in the organization have some responsibility like installation, configuring and troubleshooting, network server and software and hardware. Then, so this person must be familiar with entire ecosystem and especially understanding the characteristics of different transmission media. So while designing the computer network, the person must design the network in accordance with the performance throughput as well as security parameter also. So this network should be designed in such a way that our data traffic should be secure, our network traffic will be encrypted. So in this way, network should be designed. Similarly, we can decide which types of transmission media can be used. So if we are in industry like medical industry or some power plant or some industry where electromagnetic interference are there. So which types of transmission media should be used so that our data will be not corrupted due to electromagnetic interference. So we should use optical fiber or a copper cable or wireless communication. So accordingly, network is designed. Understanding network protocols. Network knowledge of network protocol is very important both for network administrator as well as a person responsible for handling the security operation. So basically, network protocol means it is the minimal unit of our communication. If we are accessing some website, so there are several protocols are involved behind the surfing of website. We are simply typing HTTPS something google.com. So we are getting the page. But this types of communication is actually happening over with the help of several network protocols. So how this communication is happening actually between my machine and remote machine, and what are the protocols responsible for all the communication. So person must be aware with these different types of network protocol. Ultimately, what will happen if a person is well aware with the network protocol, he or she will be capable of making decision, good decision with respect to cybersecurity devices. For example, if we want to block something in our firewall device or software, so person must be aware that to block these types of service, to block these types of unwanted traffic, we have to analyze the particular protocol. We have to analyze each traffic, and under this traffic, this protocol, we have to check the particular parameter. If the particular parameters are present, then this types of traffic should be blocked or allowed. So depending on your requirement or your analysis. So network knowledge of network protocol is very important, from HTTP, TCP, UDP, ICMP. So there are more than hundreds of protocols are there. Understanding how users are interacting with the network. So flow of communication must be known to the person handling the network and security center. The user is accessing the website from this location. The user is sending traffic from BSNL office, this BSNL office to this office. So how the data is flowing, which router is getting this traffic. So this types of visualization must be known to the person involved in managing this network. How the traffic is going, why my traffic is going through Lucknow router, why is it not going through Varanasi router. So this types of visualization should be there. Why routing is sending my traffic to wrong direction. Is something wrong with this route or this particular route, or by mistake administrator has added the wrong route. So this types of scenario can happen. So how the users are accessing the website, how users are communicating with each other should be known to the, and to manage the complex bigger network having more than 100, 200, 500, 1000 computers. Network management software must be there. Network monitoring software, network management software. So depending on which platforms you are using, there can be different types of platforms which can be used for monitoring and management of the entire network. So network management software is integral part of network as well as security ecosystem, which can display you the status of different devices. It can show you the different statistics, various statistics associated with the node device present in the TCP/IP based network. In addition to technical tasks, there are some non-technical tasks. Now, this non-technical task can be vendor interaction, customer relation, oral and written communication, documentation is very important, and teamwork will be always required. So as a team leader, you have to guide your team to make the entire network ecosystem and security system to run in a smooth manner. Now coming to inter-network and intra-network. So with respect to network, with respect to cybersecurity ecosystem, we must have a clear understanding on inter-network and intra-networking. So basically, inter-networking, as the name suggests, it is made up of two words, inter plus network. So if we are trying to connect two different networks, it will be known as inter-network. And if we are trying to connect all the nodes in the same network, it will be treated as intra-network. So you should be familiar. Your traffic is going from one network to other network, or it is propagated in the same network. So this type of understanding, this type of analysis and visualization must be there, that when I am using these services, my computer is sending traffic to other network, or it is going to only intra-network. So inter-network is created when you connect two or more different network, local area network or wide area network, with the help of router device, or router device is also known as layer 3 device or network layer device. So basically, might be most of the participants are familiar with this layer and OSI model. So the summary of layer 3, what is the logic behind the different layers? So basically, our entire computer network is very complicated. So our computer network is basically running on TCP/IP software, and this TCP/IP software was very complex. It was developed during the period of 1960 and 70. At that time, there was no proper software engineering. And TCP/IP software development was the result of conflict going between USSR and USA. So due to Cold War, due to ongoing Cold War, this development was done. TCP/IP software was the result of Department of Defense Advanced Research Project Agency. The complete funding was done by USA and their alliance country to develop a network which can sustain the nuclear or bombing attack. But there was tremendous pressure was there from political leaders from different countries that this should be immediately developed. It should be immediately implemented. So under this tremendous pressure. All of the university scientists were involved in the development of this TCP/IP software. But this TCP/IP software become very complicated. To overcome this problem, in 1984, ISO, it's International Organization for Standardization, ISO simplified this complicated TCP/IP software in the form of ISO OSI model. To understand the complex TCP/IP model in better way, the ISO divided this entire working of computer network into 7 different layers. Based on the functionality, based on the nature of traffic, the role was divided into 7 layers. So some of the roles were present in layer 1, layer 2, layer 3. So there are 7 layers. Layer 1 is known as application layer and layer 7 is known as physical layer. So there is one more layer, layer 3. So layer 3 is known as network layer. So all the operations related to networking is associated with layer 3. So our router device, our IP address, our routing, these are the part of network layer. So basically, ISO OSI model is just a paper-based model. It is not a software model. It is just a simplified, documented version of TCP/IP software. TCP/IP software is the real software we are using in our system. But ISO OSI reference model is basically simplified understanding, documented paper-based documentation to understand the entire TCP/IP model in simpler and modular way. So this inter-network means if we are trying to connect 2 or more network with the help of inter-networking device or layer 3 device or network layer device or simply router. So router is a network layer device or layer 3 device or inter-networking device. Is an example of layer 3 or inter-networking device. So when we are connecting to a different network with the help of router, it will be known as inter-network. Our internet, the actual internet is actually inter-network of many number of LANs and WANs are interconnected with the help of router. And intra-network is created when you connect 2 or more devices with the help of layer 2 or data link layer device, or simply it can be a switch or hub. So your switch device, the switch which is generally used to connect 2 or more PC in the same network. So when we are talking about the same network, it means intra-network. So when we are connecting 10 to 20, 50 PC with the help of 1 or 2 switch, it will create an intra-network. But if you are connecting the BSNL Gorakhpur and BSNL Varanasi, it means your network and Varanasi network is getting connected with the help of some router because you are located in different LAN. So this is inter-network and intra-network. And again coming to one more terminology, simply internet and intranet. So when we talk about the internet, it is generally a WAN network, wide area network, and it is a public network. Internet means we are getting connected to entire globe, entire Earth, all the network, all the WAN, LAN present on the globe. It is known as internet. So internet is basically a public network from where we are getting some resources like website, web page, audio, YouTube, all types of services are available on the internet. And intranet means it is a restricted version of small network, small internet, which is only available for the employee of the BSNL, or it is only available to the employee of particular bank. So intranet. So intranet services is limited to private use. Internet services is limited to, it is open for all public. So when we are hosting a website on a web server, Normally it means that this website should be visible to all of the users on the globe, because we have hosted our website on the web server present in the connected to the internet. But if an organization is hosting a web server in a closed area which is only available to their employee, it will be treated as website hosted in intranet. So this web server is forming a part of intranet. All the offices which are connected to each other, even by means of public network like optical fiber or any, but only their branch or offices are communicating to each other. It will be an example of intranet, because it is only available to the employee of particular organization or particular user group. So user type, any user can get connected to internet, but intranet, only the organization who have control over the intranet will decide who will use this intranet services. Security, in case of internet, security is very low. In case of intranet, the security is highly monitored, controlled with the help of administrator monitoring or managing the intranet services. Regulated by the internet are regulated by several bodies: Internet Architecture Board (IAB), INA, IETF, IRTF, ICANN. So these are the bodies, regulating bodies and standard engineering bodies which are actually regulating the entire internet on the globe. But the intranet part is monitored by a particular organization, regulated by the organization. Coverage. So internet coverage is wide, intranet coverage is limited within the organization. It can be spread over the WAN, but it is only available between the different branch office of the access, large number of users, limited number of users, system failure, unpredictable in case of internet. Intranet, if there something went wrong in the intranet based services, the administrator will always aware with the particular web server, particular server might have failed due to which this service is not available. But if a Google web page is not opening, so you cannot predict what is the reason behind it. It can be your link failure, it can be some optical fiber cut in between district, or it can be actual outage at the Google server level. Now coming to most important point, network segmentation, which is associated with cybersecurity. So our objective is to divide the large network into smaller ones. So there are two reasons to divide the large network into smaller network. One is security region and second one is performance region. So our network segmentation should be implemented. Our large network should be, our network should be designed in such a way that smaller network should be present at different locations, so that it will be very easier to manage with respect to security also, and with respect to performance, we will get the optimal performance by dividing the large network into smaller. So, so dividing a large network into smaller ones is known as network segmentation, and normally it is achieved with the help of router, switch, bridge, and different types of techniques to divide the large network into smaller network. So network segmentation, how network segmentation, why it is important? To minimize the attack surface. So if you have divided a network into a smaller one, and if something happened wrong in a particular network segment, it will affect the only particular network segment. So if you are dividing a large network into 10 networks, so only a small portion of network will get affected with a particular type of attack. So in this way, by dividing the network, by segmenting the network, you are minimizing the attack surface. Containment of breaches. So if something has been compromised in a particular segment, in a particular branch, then the only particular segment will be affected by particular types of breach or attack. By dividing this network, we can confine, we can restrict the incident to a particular region only. Improve the access control. You can effectively apply security policy at different segments based on the roles or types of device connected. So if you have a 100 branch office, you can effectively apply some rules for different branch office. But if all the branch offices are participating in a single network, it will be very difficult to manage, monitor, and apply security policy for all the PC present in the same network. Better network performance. So dividing a large network will always result in better network performance. Enhanced monitoring. Monitoring will be very easy if you divide this large network into smaller. Compliance and regulation. So basically, by dividing the different large network or customer-based network or country-based network in accordance with the compliance and regulation, for example, HIPAA-based GDPR or PCI DSS, you are keeping the sensitive component, sensitive data separate from the regular network, from the regular services. So to meet the compliance and regulation, we must have some segmentation policy in our network. You cannot have the staff computer network common with your sensitive server network. So you should always separate network by dividing the large network by means of some technology. So what are some techniques that can be used for network segmentation? At the hardware level, you can use router or switches, managed switch or bridge. So basically, now these days we are using only router and switches and firewall that can be used to divide the large network into smaller one. And with the help of this device, we can configure virtual local area network, VLAN. VLAN can isolate some of the device based on the logical configuration. Similarly, firewall can be also used to enforce the policies between different zone, different network segments. There can be internal user segment, there can be public network segment, there can be demilitarized zone segment, there can be sensitive network segment, there can be management network segment. So depending on your connectivity and firewall configuration and your organization network, you can have proper segregation with the help of firewall software or hardware. Access control list. With the help of rules, with the help of some access control, you can segregate the roles of users, you can segregate different ecosystem of the computer network. Software defined network can be also used. Although all the users are connected to the same physical network, but by means of some software defined network, we can logically separate all these different group of users logically with the help of software defined network. Zero trust architecture. So zero trust architecture is very important. Now these days, every industry is focusing on zero trust architecture. It simply means even when you are in the secure zone or trusted zone, like if employee is accessing this website, it should be allowed. So normally, what is the thinking? That if an employee is accessing this website, there should be no rule. But it might be possible that employee is the attacker, employee can be involved in malicious activity, or a computer of employee can be might have compromised by some attacker. So it is possible that with the privilege of genuine user, one can launch some serious attack on the ecosystem. So every time, whenever requests are coming from any user, whether it is an internal user, management user, our CEO, our GM, every user should be treated as zero trust in the zero trust model. We cannot trust on any user due to any reason, because any user computer can generate a ransomware traffic, any malware traffic. So at least if the requests are coming from some system, we should have some mechanism like zero trust architecture. Every request, every traffic which is coming from known or unknown area should be authenticated, should be verified on dynamic base. So dynamically. So identity of device, identity of user, identity of services must be verified before granting any access. Then subnet. So there are many ways to segment the entire network. Some of them are logical division, some of them are physical division. So with the help of VLAN, you are achieving the logical division of computer on the same physical field. Subnet. So subnet is something in which you are dividing a large network into smaller ones by using IP addressing and IP subnetting. So subnetting is a way in which we can create multiple different networks logically, and this subnet information can be assigned to different networks. Microsegmentation. So microsegmentation is more granular form of segmentation, means under each particular segment there is a further segmentation done on the basis of some policy, on the basis of some rules and regulations with the help of firewall. For example, under internal user group, under internal network, there are 4 categories of user. For each category of user, there should be some different rule, network rule should be there. Physical segmentation. Physical segmentation means physically you are isolating the sensitive information. So some of the network can be physically separated from the regular corporate network, from the regular college network, because they are having some sensitive data, examination data, policy data, company secret data. So this type of physical segregation or segmentation can be done. Then network access control can be applied on the basis of policy with the help of some network access control devices or software. Network address translation. So NAT can also hide some details of internal user. So network address translation can also use to segment the network between private and public network. So in this way, the internal details of all the users of the organization will be hidden to the outside world. So these are the some techniques for segmentation. Coming to LAN traffic congestion. So it is not associated with the cybersecurity, but if there is a particular type of attack launched by a malicious user, which is resulting in the traffic congestion due to unlimited usage of traffic on the network, by bogus traffic, by unlimited downloading. So this can result in some congestion. So what is the reason behind regular network traffic congestion, LAN congestion? Excessive broadcast traffic. So there are 3 types of communication are there in the computing world. One is unicast, second one is multicast, and third one is broadcast. So this terminology is very important for ethical hacking also. Because many times we have to identify this attack is broadcast based or unicast based or multicast based, and the protocol can be harmful or not, because which attack is prone to this types of attack, which protocol is prone to particular types of attack. So which protocol is broadcast based protocol, which protocol is unicast based protocol. So all this understanding should be there. So excessive broadcast traffics are coming from too many devices. So broadcast means a computer, a software, a TCP/IP software generates different types of message. One is unicast. Unicast means one to one. Some is multicast, one to a group of computers. A broadcast means one to all in the same segment or same network. So if I am giving some lecture in a classroom, my voice is going to all the students present in the classroom. It is a broadcast for this particular classroom. But if it is disturbing the other classroom, because the other classroom are near to my classroom, My voice is actually crossing the physical boundary of classroom and going inside the second or third classroom. So in this way, my broadcast is disturbing some other user also. So my broadcast should be controlled. My voice should be controlled. Similarly, network broadcast, computer broadcast should be sent, propagated in controlled manner. And it can be possible that some of the services depends on broadcast traffic, and due to heavy usage of this service, the broadcast naturally heavy broadcast traffics are coming. But there can be some attacks which can generate lot of broadcast traffic. So which can result in slow down of the network, which can result in slow down of service or completely shutdown of service. So excessive broadcast traffics are coming, can be a reason behind the LAN traffic congestion. Network overloading can be reason that due to more number of devices connected in the network, more number of users are accessing the service more than the bandwidth allowed in the network. So bandwidth is the capacity of any media or device, maximum allowed data that can be handled per second. Maximum data to be downloaded or uploaded by the device, like 1 Mbps, 1 megabit per second. So it can be bandwidth. So bandwidth is the maximum allowed capacity of the media or device. If a switch device is labeled as 100 Mbps, means it is capable of handling maximum 100 megabits per second on each port. It cannot transmit 200 Mbps. So we are trying to connect more device, more number of users, and these users are actually downloading more traffic, sending more traffic. So this can be reason behind the LAN traffic congestion. Collision on the network. So due to multiple devices are sending simultaneous traffic on the shared media, and it is leading to the collision. So due to lot of collision happening between data coming from different source, it can be reason behind LAN traffic congestion. Inefficient network design. So poorly structured, poorly designed network can be a result of LAN traffic congestion. You have not divided the large network into a smaller one. You have forcefully connected 3000 computer with the help of multiple switch. So it is a very bad example of network design in which 3000 computers are connected with the help of 20 different switches, and all switches are continuously connected with each other. So this is the outdated hardware. Some older hardware may have some low bandwidth, low capability, heavy file transfer. Regular file transfers are getting between heavy usage of traffic like streaming services, video streaming, audio visual. A lot of backups are getting transferred. Regular backups are getting transferred. High bandwidth application is being used. Misconfiguration network devices. Unnecessary multicasting. So excessive multicasting traffic can be also reason behind LAN traffic congestion. Like excessive broadcast, there can be excessive multicast traffic can be there. High usage of streaming services, spanning tree loop. So this is the problem generally faced by. So this spanning tree loop can be generated unintentionally, or it can be generated by malicious actor by using some tactic to create loop in the network. So many times our students create this types of mischief activities to bring down the network by using some sorting technique, cable sorted, or a switch is connected. Suppose port number 1 is having some cable and it is connected to port number 2. So a loop is created, a physical loop is already created, and inside the switch there is a virtual loop is created. So due to this virtual loop, what will happen? Every traffic will come to this particular switch because it is the shortest path. And due to this shortest path, we will be never in position to send our traffic to the regular right destination. So spanning true loop can be reason behind the land traffic congestion. Now coming to one more term, collision domain and broadcast domain. So collision domain and broadcast domain, these two terms are associated with networking devices, and collision domains are mainly associated with the performance, but broadcast domains are associated with the security. So what is collision domain? Collision domain means networking devices that share the same medium are connected to same physical segment are said to belong to the same collision domain. It means if you have a single medium means single physical medium, or it can be a shared medium on which many computers are connected, and because there is only one medium channel is there, you cannot transmit more than traffic from more than one PC at the same time, because only one channel is there. So taking the example of our highway, if there is a two-way road, we can run two vehicles at the same time. If there are four-lane road, four vehicles can be run simultaneously without any collision. So similar is the case in the networking device. Each networking device has some number of communication channels. More number of communication channel means more number of paths will be available for simultaneous transmission from different PCs. So if there is a only single communication channel is available and two PC try to transmit data at the same time, what will happen? Collision will happen and data will get lost. So a collision domain refers to network segment where data packets can collide with each other when multiple devices try to send data simultaneously. So our objective is to use the networking device which is having more number of communication channels, more number of collision domain. More number of collision domain means more number of communication channels are available in our device. For example, hub device have only single collision domain because on their motherboard there is a only single communication path are available in case of hub. So in case of hub, only one PC is allowed to transmit data at the same time. Two or more PC cannot transmit data simultaneously because only one communication channels are available and only one collision domains are available in case of hub. So some points about collision domains are they are common in half duplex. Every half duplex device or network have single collision domain. Like hub is an example of half duplex device. So hub is an example of half duplex device, and any communication system which is having half duplex communication mechanism will have single collision domain because you cannot transmit bidirectional communication at the same time due to restriction, due to limitation of communication channel. Switch and router have multiple collision domain options because they have multiple separate communication channel available for each connected device. So more number of communication channel means more efficient the device will be. So our switch, our router device are known as full duplex device, and our NIC card, which is present in today modern PC, like generally this day we are getting the full duplex NIC card. The full duplex Ethernet card, NIC card is also example of transmitting data, incoming, outgoing data at the same time. So there will be no collision. So basically we are talking about mainly hub and switch. Hub is only have only single collision domain, it means only one PC can be allowed to transmit data at the same time. Other PC needs to wait until the communication channel becomes free. But in case of hub, if there are 12 PC connected to a switch, in case of switch, if there are 12 PC connected to 12 ports, what will happen? All 12 PC can transmit data at the same time because internally, parallelly, there are 12 independent channels are present on the motherboard of, on the circuit of switch device. There will be no collision if all these 12 PC try to transmit data at the same time in the same direction or opposite direction. There will be no collision. So more number of collision domain, more throughput will be there, more efficient device will be there. So that is why hub is discouraged, hub is not used, and this day hub is not available in the market. Only switch device is available in the market. Now coming to broadcast domain. So this broadcast domain is associated with the example, what example I have taken. For example, my classroom example. So I am taking a lecture in a particular classroom. My voice should be audible to only students available in this particular subject class. It should not cross my classroom boundary. Otherwise, it will disturb the other students sitting in the other class. Similar is the case of broadcast domain. How many devices are listening to a particular broadcast message? If I am sending a broadcast message, how many devices are hearing this broadcast message, are seeing this broadcast message? It means what is the limitation, what is the perimeter of this network, what is the area where this broadcast will be propagated. So a broadcast domain is a computer network refers to a group of devices that can receive broadcast frame from any other device in the same group. So which services use broadcast traffic and why broadcast should not be transmitted to other network? There are many reasons. So normally broadcasts are propagated by layer 2 device, switch device. When we send a broadcast message, suppose my laptop is sending a broadcast message. So this broadcast message can be generated by any services, or we can manually generate the broadcast traffic so that my computer will send this broadcast message everywhere in the same network. So all the other computer which is connected in the same network will receive this particular broadcast message. And my computer is generating a broadcast message will be not forwarded to other network, other department, other lab, or other network, because router device, layer 3 device by default block all the broadcast message coming from one network to other network. It restricts, it do not allow the broadcast to go from one network to other network. So by default, every broadcast traffic is blocked by router. So it is very important point. Otherwise, what will happen? My laptop broadcast traffic will be propagated everywhere on the internet, and it will lead to network congestion. And security reason, for security reason, this can be also dangerous, because my computer is generating some broadcast traffic which is meant for only local user. But if it is being transmitted to entire globe, it will be very dangerous. So there should be some mechanism which can restrict the broadcast of a network. So router by default restrict the broadcast message, and switch and hub device propagate the broadcast message. So if you have connected multiple switch with each other, it means the one PC which is generating a broadcast message and connected to first switch, will be propagated everywhere. अगर नेटवर्क में 100 स्विचेज लगा के आपने आपस में कनेक्ट कर दिया है और एक सिंगल पीसी ने ब्रॉडकास्ट जनरेट किया, तो दिस ब्रॉडकास्ट विल बी प्रोपोगेटेड एवरीवेयर थ्रू दिस इंटायर सीरीज और चेन ऑफ स्विच. So we have to identify which application, which services generate the broadcast traffic, which services depends on unicast and multicast traffic. So broadcast domain and security. Why broadcast domain is important? Because there are some types of attack which is based on broadcast based protocol. So those protocols which are based on broadcast based messaging system are generally vulnerable to broadcast based attack. So this broadcast domain and security is very important. First thing is that broadcast domain means we are trying to segment our network. So if there is something wrong happen with the help of broadcast message, if a ransomware is using the broadcast types of communication system and being broadcasted with the help of infected system, it will affect to all the computer in the same broadcasting. So if we have a network segmentation, it means we have divided this broadcast domain into smaller broadcast domain. So if it is something is happening wrong with the help of broadcast traffic, it will be restricted to a small segment of broadcast domain because we have divided this broadcast domain. So this virus, worm, malicious application can be propagated with the help of broadcast. Not only malicious application, there are some types of denial of service attack, DOS attack. So DOS attack can be targeted to a particular broadcast domain, and if there are number of बहुत ज़्यादा कंप्यूटर अगर होंगे तो सारे इसके victim बन जाएंगे. But if you have divided this large network into smaller, the only small part will get victims of this particular types of DOS attack. Mitigating broadcast storm. तो लॉट ऑफ एक्सेसिव ब्रॉडकास्ट स्टॉर्म हमेशा नेटवर्क की परफॉर्मेंस को डाउन करेगा और डिनाइल ऑफ सर्विस सिचुएशन अराइज होगा. ट्रैफिक मॉनिटरिंग. तो वी विल गो इन डिटेल ऑफ DOS अटैक ऑन इन सम अदर मॉड्यूल. तो ट्रैफिक मॉनिटरिंग, तो विद द हेल्प ऑफ स्मॉलर ब्रॉडकास्ट डोमेन, ट्रैफिक मॉनिटरिंग विल बी वेरी इजी. Attack vector for ARP spoofing. ARP is a protocol, address resolution protocol. So ARP is a broadcast based protocol. ARP spoofing attack. So this attack will be covered in some other topic. So basically, what I am trying to explain, broadcast domain is very important. We have to limit our broadcast domain. We have to restrict our broadcast domain by using some router device, because broadcast domain ARP spoofing attack can be possible in same broadcast domain. Man in the middle attack. Man in the middle attack can be achieved with the help of ARP spoofing attack. And ARP spoofing attack can be achieved with the help of ARP broadcast message. It means if attacker is sitting in the same network, he or she can target only the system present in the same broadcast domain with the help of ARP attack, ARP based man in the middle attack. Containment of malicious activity. So with the help of control broadcast domain, smaller broadcast domain, limited broadcast domain, you can restrict malicious activity to a smaller broadcast domain, to a particular broadcast domain only. So segregating broadcast domain using router or VLAN. So VLAN can also help in creating different broadcast domain. तो आप VLAN या राउटर का यूज करके आप मल्टीपल ब्रॉडकास्ट डोमेन अलग अलग सेपरेट क्रिएट कर सकते हैं. और एक VLAN में अगर मालवेयर इन्फेक्टेड हो भी जाएगा तो मैक्सिमम चांस है कि it is not going to infect other VLAN, but it depends on scenario. If you have allowed all the traffic from one VLAN to another VLAN, inter VLAN routing is configured, then these things can be possible. But if you want to logically separate some of the computer with the help of software configuration, then VLAN configuration can be done. So again, coming to collision domain and broadcast domain, a hub creates one collision domain by default, naturally, and one broadcast domain. तो hub के केस में one collision domain और one broadcast domain ही रहता है. One collision domain means at a time only one PC will be allowed to transmit the data. Not more than one PC can be allowed to transmit the data. And one broadcast domain in case of hub means if any of the PC connected to the hub device is sending a broadcast message, it will be propagated to all of the PC connected to this hub network. And if this hub is further connected to second hub by means of some cable, this broadcast message will be propagated to second hub also, and all the devices connected to second hub. Coming to switch, I will cover brief later. Coming to switch break up collision domain because there are multiple communication channels are available inside the switch device. So if there are 24 ports on a switch, 24 PC can parallelly transmit the data without any collision. So more throughput, more efficient device will be there. And but create one broadcast domain by default. So what does it mean? By default, switch have a one broadcast domain means if any of the PC is sending the broadcast message, it will be propagated everywhere. But here, by default word is mentioned, it means we can configure, we can break this broadcast domain by means of VLAN. So if an administrator has configured virtual local area network on a managed switch, suppose 5 virtual local area network is configured on a single switch. It means there are 5 separate independent broadcast domains created. If a PC of a particular VLAN is sending a broadcast message, it will be propagated only to the PC in the same VLAN. It will be not forwarded to PC of other VLAN. So this is the benefit of creating VLAN, virtual local area network. So by means of the VLAN is normally created to segregate the large network into smaller one to secure a particular segment. We want to protect some particular network. We want to isolate some of the network. With the help of same physical switch, we can configure virtual local area network. So if there are 5 VLAN created in the switch, it means 5 different independent broadcast domains are created in the switch. So by default, there is only one broadcast domain present in switch. In case of managed switch, if administrator has configured multiple VLAN, there will be multiple broadcast domain will be there. In case of router,
Adi, how's life? लगा बुखार था कि नहीं? बुखार था.
in case of router break up broadcast domain as well as collision domain. So if there are multiple networks connected with the help of router, each network broadcast traffic will be not propagated to second network, third network, or fourth network. For example, my laptop is connected to one of the network of Nailik Group. So if I am sending a broadcast message, my router, my gateway will block this traffic on the gateway level. It will be not forwarded. Only unicast traffic will be forwarded to other destinations. Suppose I am accessing some website google.com. So my router will allow this types of incoming requests on their device. So these types of traffic will be allowed. But if I am sending a broadcast traffic, so this broadcast traffic will be blocked at the gateway level. Gateway means an IC card of the router to which our switch is connected. जिस एन आई सी कार्ड से हमारा स्विच कनेक्ट है, जिस स्विच से मेरा लैपटॉप कनेक्ट है, तो वो जाके फाइनली गेटवे पे आपकी ट्रैफिक जाती है. देन द गेटवे विल डिसाइड वेदर टू अलाउ और डिनाई. The unicast types of traffic will be allowed, but broadcast traffic will be blocked by default by router. So router have multiple broadcast domain and multiple collision domain. Multiple collision domain means if a router is connected to 4 different networks. One network is connected to BSNL Gorakhpur, one is connected to BSNL Varanasi, BSNL Kolkata, BSNL Delhi. So if all these different BSNL offices are sending data in the same direction or opposite direction, there will be no collision inside the router. And the broadcast traffic originating from a particular BSNL office will not affect the other broadcast domain, other network. And bridge is basically because bridge today bridge device is obsolete, but academically, theoretically, we should know about the bridge. Bridge, you can treat bridge as a 2-port switch device, a switch with 2 ports. ऐसे स्विच जिसमें 2 पोर्ट होंगे उसको ब्रिज की तरह आप ट्रीट कर सकते हैं. इट मीन ब्रिज ब्रेकअप कोलिजन डोमेन. So because bridge have 2 ports, so there will be 2 collision domain. At the same time, 2 different segments can transmit data parallelly without any collision, but create 1 broadcast domain. So if any of the PC connected on the bridge of any of the particular side is sending a broadcast traffic, it will be propagated everywhere to all the devices. So coming to this diagram, it is a hub symbol. So when we create a topology with the help of hub, it is a symbol of hub. And suppose this PC is sending a broadcast message. So this broadcast will be propagated to this PC, second, third, fourth. So this will create a single broadcast. And what will happen if all this PC try to transmit data parallelly? There will be collision inside the hub. Only one PC will be allowed to transmit the data. And there is one more problem with hub. This broadcast problem is there, but broadcast message is meant for one to all. It is not a problem, but problem is, what is the problem? Even in case of hub, if this PC is trying to send a unicast message, this unicast message will be also broadcasted. Because hub is not an intelligent device, hub will always broadcast any types of traffic, whether it is a unicast, multicast, or broadcast. It will be always broadcasted. It means unicast based traffic. Suppose this PC wants to communicate with second PC. So unicast traffic will be generated. So it should go to hub, and from hub it should come to second PC. But it is not like the case, because hub always broadcasts the traffic irrespective of nature of original traffic to unicast, multicast, or broadcast. So this traffic will be propagated everywhere. Other PC will ignore, only the destination PC, the desired PC will entertain this traffic. But what will happen if a attacker is sitting, or malicious user is sitting on this fourth PC? They will be able to capture all the interesting traffic from the unicast communication. Okay, so there is a 1 collision domain and 1 broadcast domain in case of hub. In case of B is a symbol of bridge. This is the bridge symbol. Here, bridge is further connected to hub. Hub is further connected to 2 PC. Similar is the case of opposite side. So if this PC is generating the broadcast will go to this PC also. It will go to bridge port also. Then bridge will forward this broadcast message to second segment. Again, this hub will propagate this broadcast message to every PC. It means entire topology of B will form a single broadcast. And in case of collision domain, if these two PC try to transmit data at the same time, there will be collision happen at the hub level. तो hub में ही collision हो जाएगा. Similarly, ये PC भी अगर ये दोनों PC भी data transmit करते हैं, तो इनका collision इसी hub level पे ही हो जाएगा. लेकिन if this PC is sending data in this direction and this PC is also sending data in this direction, there will be no collision happen in the bridge because bridge has two collision domains. So यहाँ पे two separate channels available. Coming to C is a switch. It is a symbol of switch. The switch is connected to 3 PC and further it is connected to hub. Hub is further connected to 2 PC. So what will happen if any of the PC send a broadcast message? It will be propagated everywhere. Because switch also propagate the broadcast message and hub always propagate the broadcast message. But in terms of number of collision, because in case of there are multiple device which hub is there, so we will calculate on the basis of switch. So higher priority will be decided by switch. So there are 1, 2, 3, 4 links are connected to this switch. अभी switch से 4 links connected है, तो डेटा इधर से भी आए, इधर से भी आए, इधर से भी आए, इधर से भी आए. पैरेलली चारों डायरेक्शन से इस स्विच में डेटा आएगा, कोई कोलिजन नहीं होगा. बट ये दोनों पीसी के जो डेटा ट्रांसमिट होंगे तो वो हब लेवल पे ही कोलिजन हो जाएगा. लेकिन इसमें से कोई एक पीसी का और ये तीनों पीसी के एक साथ ट्रांसमिशन होंगे तो कोई कोलिजन नहीं होगा. तो टोटल नंबर ऑफ कोलिजन डोमेन विल बी 4. 1, 2, 3, 4. नीचे डी में राउटर है. दिस इज अ राउटर. राउटर इज कनेक्टेड टू 3 डिफरेंट सेगमेंट. This is one line, this is second line, and this is third line. Each line is having a hub. दूसरा hub है, यहाँ पे third hub है. So there will be 3 broadcast domain. This broadcast will go to here. यहाँ का broadcast इसमें आएगा. इसका broadcast इस gateway तक आएगा, इस point तक. And router will not forward this broadcast message to other network. Similarly, इस network का broadcast इन दोनों PC तक रहेगा. उसके बाद इस गेटवे तक ये ब्रॉडकास्ट जाएगा. ये एक दूसरा ब्रॉडकास्ट डोमेन होगा. सिमिलरली यहाँ का ब्रॉडकास्ट इन चारों पीसी तक जाएगा और इस गेटवे तक आके ब्लॉक हो जाएगा. तो ये एक थर्ड ब्रॉडकास्ट डोमेन क्रिएट कर रहा है. तो इन राउटर, डिपेंडिंग ऑन नंबर ऑफ डिफरेंट नेटवर्क कनेक्टेड with the help of router, there will be different independent broadcast domain will be there. And how many collision domain will be there with respect to router? अगर यहाँ से भी डेटा चला, यहाँ से भी डेटा आया, यहाँ से भी डेटा आया, तीनों आपस में कोलाइड नहीं होंगे ड्यू टू प्रॉपर्टी ऑफ राउटर. राउटर सपोर्ट मल्टीपल कोलिजन डोमेन. Now coming to next topic, broadcast based protocol. So we will go in the details of protocol, different types of protocol, OSI model based protocol supported in different layers. But for the point of broadcast domain, we should be aware that how many protocols are dependent on broadcast based messaging system. So there are some protocols are there, and with the help of this, you can get aware that this type of protocol might be used for broadcast based attack, or this types of attack will be possible in only a particular broadcast domain. So ARP protocol will be explained in next few slides. So this ARP protocol, DHCP, dynamic host configuration protocol, routing information protocol, NetBIOS, spanning tree protocol, link local multicast name resolution protocol, wake on LAN, ICMP protocol, IPv4, auto configuration messaging. All these protocols are based on broadcast based communication mechanism. So their mechanisms are dependent on broadcast based traffic. So if there is something wrong, if there is some loophole or weakness in a particular protocol, attacker can misuse this protocol with the help of broadcast messaging system. So all this will be covered in next slide. So this is the description of different types of protocol. So these protocols are broadcast-based protocol. It means if a ARP-based communication is traffic is generated by PC, this ARP traffic will come to this PC also and up to this gateway. So this is the propagation level of this ARP. Similarly, DHCP means DHCP is used for configuring IP address automatically with the help of DHCP server. It means DHCP-based traffic can be restricted to a particular broadcast domain only. So if a DHCP server is connected on this network, suppose DHCP server is there, this PC is acting as a DHCP server. So other computer, these three computers will get the IP address from DHCP server, but this computer will not get any IP address from this DHCP server because DHCP-based mechanism are totally dependent on broadcast-based communication. So if there is a router in this network, the DHCP traffic will be also blocked. So these are the list of broadcast-based protocol. Then there is a transmission mode. So there are different types of transmission mode. So one was already discovered, that unicast, multicast, and broadcast types of communication. Again, there is a transmission mode type, simplex mode, half duplex mode, and full duplex mode. So simplex mode communication means one-way communication. Only one-way communication is allowed. Bidirectional communication is not allowed. Half duplex means bidirectional communication is allowed, but not at the same time. If I am receiving something, I cannot transmit something to other user because currently I am in half duplex. Full duplex means bidirectional communication can be possible at the same time parallelly without any issues. So both directions parallelly can happen in case of full duplex communication. So there are some examples. Simplex communication means TV broadcast. TV broadcast, our TV remote, radio broadcast, keyboard. So whatever keystroke we are pressing is going to the processing unit, but the processing unit cannot send something on the keyboard. So we are talking about the old keyboard, not the modern keyboard. So our keyboard cannot receive data back from the. Similarly, fire alarm. Similarly, half duplex device, walkie-talkie, CB radio, community broadcast radio, RS-485. RS-485 is a communication cable communication technique which is supported in half duplex mode. Legacy Ethernet card, hub device is half duplex device. So due to half duplex device, hub is less efficient device. Full duplex means both way bidirectional communication will be possible at the same time. So our Ethernet card is always capable of sending full duplex communication, चाहे वो NIC कार्ड वायरलेस हो या वायर्ड हो, full duplex communication होता है. Telephone, modern telephone, fiber optic, cell phone, Bluetooth device, router, switch, wired NIC card, wireless NIC card, all these devices can operate in full duplex mode. What will happen if we try to connect hub and switch both in the network? So hub will create the bottleneck because hub is a half duplex device, switch is full duplex, and PC is full duplex. So the communication between PC to switch will happen in full duplex mode, faster, more efficient, but overall communication will reduce at the level of between hub and switch. तो switch और hub के बीच में overall communication half duplex mode में हो. तो यहाँ पे efficiency हमारी घट जाएगी. तो अगर ये पीसी यहाँ के हब से कनेक्टेड पीसी से कम्युनिकेट करेगा तो ओवरऑल परफॉर्मेंस उसकी हाफ डुप्लेक्स मोड में आएगी. एंड द स्विच कैन ऑपरेट बोथ इन हाफ डुप्लेक्स, हाफ फुल डुप्लेक्स. आवर एनआईसी कार्ड कैन ऑपरेट इन फुल डुप्लेक्स एज वेल एज हाफ डुप्लेक्स मोड. तो डिपेंड्स ऑन कि अदर एंड इज सपोर्टिंग फुल डुप्लेक्स और हाफ डुप्लेक्स. तो यहाँ पे पीसी ने अपने को हाफ डुप्लेक्स मोड में सेट कर दिया. So this is not related with the cybersecurity topic, but for performance throughput related matter, this point should be noted by administrator. Half duplex and full duplex. Not only hardware device are half duplex and full duplex, even the network protocols are also operated in half duplex mode and full duplex mode. For example, TCP protocol, transmission control protocol, operate at full duplex mode, but UDP protocol operate in half duplex. So it depends on different scenario also. Now coming to Ethernet, because we are talking about the LAN technology, we are describing the LAN, WAN. So the most common network technology is Ethernet or local area network. So when we are getting connected to a switch or hub device or router device, our data is being transmitted in the form of frame. So this frame is actually defined by Ethernet family. So Ethernet is a family of frame-based computer network technologies for local area network. Ethernet is widely used networking technology that facilitates communicating within a local area network. Ethernet operates on a wired system using cables such as twisted pair or fiber optic. Ethernet allows for both full duplex. So it means Ethernet card, our NIC card, which is generally Ethernet based, it have support for full duplex and half duplex communication, depends on the status of other remote device connected to our device. So Ethernet defines the number of wiring signaling standard for the physical layer. So again, there is a physical layer means layer 1. So layer 1 is a physical layer. So physical layer of OSI model is mainly related with all the AVC and fundamental of wiring, signaling technique, and electronics and communication, multiplexing, duplexing, frequency band. All these things are part of physical layer as per OSI model. So Ethernet defines how many wires will be there, what will be the voltage, what will be the signaling standard with respect to different wire, what will be the connector, which pin will send the plus 5 volt, minus 5 volt, 0 volt. So these types of things has been defined in this Ethernet. In addition to Ethernet, there are more number of network technologies like token ring, FDDI, ATM, frame relay. So these are the different networking technologies in addition to Ethernet. So for local area network, we normally use Ethernet. And as per IEEE, Institution of Electronics and Electrical Engineer, IEEE had assigned a number, given a number, a specification to Ethernet technology at 802.3. So whenever you see 802.3 in the specification of switch device, hub device, or any Ethernet card, it means we are talking about the Ethernet. If you see 802.11, it means we are talking about the Wi-Fi technology. If something is mentioned 802.15, it means it is related to Zigbee or WiMAX. If it is .16, it is Zigbee, or no, .15 is something related to WiMAX. So IEEE assigned these numbers for different technologies. So Ethernet has got the 802.3. CHMA-CD. So CHMA-CD is a mechanism in the TCP/IP based communication. It is an algorithm. Basically, we need not to implement this CHMA-CD because it is a part of algorithm. So it is a method by which our TCP/IP node detect the collision in the network, and there are some methods are there that can avoid the collision also. So it is known as CHMA-CD. So there can be different types of transmission media, guided and unguided. In the guided, there can be different types of cable, coaxial cable, fiber optic cable, twisted cable. Under twisted cable, with respect to LAN technology, we can have unshielded and shielded twisted pair cable. And under the fiber optic, there can be two types of fiber, multi-mode fiber, single mode fiber. In coaxial cable, there can be baseband cable and broadband cable. And under unguided media, there can be radio wave, microwave, infrared. Under radio wave, there can be Wi-Fi 802.11 ABC. There can be Bluetooth. So these are the different types of transmission media. So this is the details of coaxial cable. I am skipping this part. If you are interested, and you can go through the description given in the different types of cable. Coaxial cable, twisted pair cable. So because twisted pair cable are mostly used in local area network, and normally you will see this cable in your network also. So these cables are very common in the Ethernet standard. There are 4 pairs of cable, color coded in different color combinations. So these 4 pairs of wires means total 8 wires are present inside the twisted pair cable. And this is the most common cable used in the LAN technology. And with the help of this cable, we can connect our laptop to a switch, a hub device, a router. A router can be connected to second device. So all the Ethernet-based connector, Ethernet-based communication can be connected with the help of twisted pair cable. There are 2 types of twisted pair cable, UTP and STP. UTP means unshielded twisted pair cable. All wires are wrapped in a single plastic jacket, plastic covering. These are the plastic covering and without any metal protection. It is known as UTP cable. And if there is any metal shielding is there, a additional layer of protection is there, it will be known as shielded twisted pair. So these shielded twisted pairs are used where electromagnetic interference are there. So normally it is used in the industry or where there is a electromagnetic signals are there in the surrounding, then STP cables are used. Both UTP and STP are similar with respect to throughput 10 Mbps. This cable come in different transmission rate, 10 Mbps, 100 Mbps, 1 Gbps, 10 Gbps, 100 Gbps. So there are different transmission rates supported by STP, UTP cable depending on their category of the cable. Only difference is that STP is having more material, more protective shielding is there, and that is why it is more expensive than the UTP cable. Both cables are connected with the help of RJ45 cable connector. RJ45 connector, RJ stands for registered jack. STP provides noise and EMI resistance than the UTP cable. Maximum segment length for both types of cable is 100 meter. So this is the limitation of UTP and STP cable. Up to 100 meter, you can transmit the data. Beyond 100 meters, you have to connect the repeater device. So you have to use the Ethernet repeater to extend the length of 100 meter to 200 meter, 300 meter by connecting repeater device. theoretically, maximum 1024 node can be used in the UTP based segment. So maximum data from maximum 1024 node can be transmitted with the help of single UTP cable, because there are some signal rates are associated with the cable, and due to this calculation, maximum 1024 node can transmit data at the same time with the UTP or STP cable. So this is the UTP cable. There are 4 pairs of wire with different color coding. So this different color coding are very important at the network engineer level, the person involved in troubleshooting of this cabling. This color coding is very important to identify the correct pairing. There are different categories of twisted cable, whether it is UTP or STP. Cat1 starting from Cat1 to Cat7. Latest one is Cat7 and oldest one is Cat1. Cat1 have maximum bandwidth support of 1 Mbps, 1 MHz signal rate, Ethernet standard, not used for data. Basically, Cat1 twisted cable was not used for transmission of computer binary data. It was mainly used for telephone communication. Cat2 is 4 Mbps, 10 MHz signal rate, token ring. It was used for token ring. Similarly, Cat3, 10 Mbps, 16 MHz, 10 base T Ethernet. It is also known as 10 base T Ethernet. 10 means 10 Mbps, base means baseband signal, and T means twisted cable. T stands for twisted cable. Similarly, Cat4, 20 Mbps token ring. Cat5 cable is supported with 100 Mbps, 100 megabits per second. Small b is coming means bit. Capital B hota to bytes. So 100 megabits per second, 100 megahertz, 100 base T Ethernet. Cat5 is 1000 Mbps means 1 Gbps with 1000 base T. So this type of standard will be printed on the plastic jacket of cable. Cat6, 10 Gbps, 10 Gbps T Ethernet. Cat6A, 10 Gbps, 10 gigabit G base T Ethernet. Cat7, 10 Gbps, so not drafted here. So basically, Cat6 is the latest standard, but Cat7 is also available in the market. So Cat1, 2, 3, 4, 5 are outdated because of low bandwidth. Cat6 is the commonly used twisted cable. So these are the different categories of twisted cable, and maximum supported range is 500 meter for 10 base 5, 802.3, and for 802.3, 10 base 2 is 185. So these are the range, IEEE standard cabling method topology, speed duplex type, half duplex, and it is used for full duplex. So this type of description is there.